Hi everybody, hope you all had a good week. This is going to be the studio review for Studio 7. This week we saw a very big, important concept, this idea of objects. So we're going to be using objects from now until the end of the semester. In fact, everything that you've kind of been working on up until this point is sort of been leading you to this idea of objects. And it's an important concept within computer science as a whole. You'll see objects appear not just within this class, but other computer science courses that you take, and also just out in the world. You may have heard of this idea of object-oriented programming. That's what we are getting ready to introduce you to. It is what's known as a programming paradigm. So programming paradigm is sort of the way that we view the world, or the way that we see our programs. And so within object-oriented programming, we view everything as an object. And Java, the programming language, is very famous for that. It sees everything as an object. That might make a little bit more sense as we create more objects and use more objects. But you might run into other programming paradigms as you explore and become a better programmer. So procedural and functional programming paradigms are some more common programming paradigms that you may run into in other languages like Python or C. But object-oriented programming is very popular and dominant for a reason. It's a very sort of natural way that humans see the world, as objects around us that can be manipulated. And so the idea is that we're just going to try and create code that can allow us to create and manipulate those objects in much a similar way as we would expect to in the real world. We're just doing it on the computer. So for the studio, it's a lot more open-ended. We had you think a lot more about how to design these objects. What should go in these objects, how they should behave. And so for the review, I'm going to create a couple of these objects. I'm going to focus on rectangle and fraction. And then I'll spend some time talking about assignment 7 as well. But let's go ahead and hop right into it. There are two major parts of every object. We have our instance variables, which are usually going to be found up at the top. Those are the properties. Those are the attributes, right? And we have a phrase that we use to help us make those connections. This phrase has a is a good phrase to remember when trying to distinguish instance variables. So we see right here a rectangle has a length and a width. That's a good clue that length and width should be instance variables. The fact that I can say this and it sounds logical, it makes sense, right? Tells me that these are good candidates for my instance variables. And we'll add them to our code in just a moment. Before I do that though, let's think about what might fail this test, right? What might not be good instance variables. So you could say something like a rectangle has a hair or eyes, right? And so in some contexts that might make sense if we're doing a cartoon or something, but in this context it doesn't. In this mathematical context, that doesn't make sense. Or you might say something like a rectangle has has a computation of its area, which is technically true, but computing the area is more of a verb. It's more of an action. So that is going to be something that we, one of the other parts of our objects, of our classes, which is a method, defines things like behavior. So if you say it out loud and it sounds a little awkward, that might be an indication that it doesn't belong in this object, or it's maybe a behavior as opposed to an instance variable. For the purposes of this problem, we'll stick with the two that are listed here. I've got two instance variables, length and width, and I'm going to go ahead and include them right away at the top of my file, and I'm going to mark them as private. I also have to decide on the type. I think most people naturally, would fall to a double for the length and the width here. It was mentioned in the textbook that these should be marked private. I'm also a big proponent of marking all instance variables as private in this particular language. I'll talk about why that is just a little bit later. But before I get to that, I want to introduce a very important method that you're going to see in every class that is related to the instance variables, called the constructor. So I'm going to go ahead and create a constructor here next. The constructor is a very special kind of method. It's responsible for creating one of these objects, for bringing an object into the world. And in order to do that, its main responsibility is to make sure that these instance variables have values by the time that the constructor is finished. So there's a couple of ways that we can do that. one way that we can do that is we can just type in values, right? I could just say length is equal to 9 here. And so when I call the constructor, I know that the length is going to be set to 9. This is somewhat limiting. So, limiting in the sense that I only have the ability to create rectangles with a length of 9. And there are lots of different kinds of rectangles of many different kinds of lengths that I may wish to represent. So this might be appropriate in some situations. Let's say I am creating a person, right? A baby. The age of that baby when it's first created might be considered to be 0, right? It was just made, it was just born. Your age is going to be 0. Sometime later on, you may increase your age, right, as time goes up. But it could be wise to sometimes code things in as constants, if that is in fact true, at the beginning of every object. But for values that we wish to be able to modify, for values that, if we wish to be able to customize our object in certain ways, then we need to provide parameters to our constructor to allow for that. So I'll add both length and width in as parameters. And you can see here's a common mistake that people will run into. You'll notice that the names of my parameters, the names of my instance variables are the same. This in itself actually isn't a bad thing. I do stuff like this all the time. But these lines of code look a little bit confusing, and you can see Eclipse is a little bit confused as well. It doesn't know necessarily which one I'm talking about, so it has to make a choice, right? I wasn't specific enough to tell it whether I was talking about this one or this one, so it had to make a choice, and it just grabbed the closest one that it could find, which is this one. But for the length on the left side and the width on the right-hand side, remember, the role of our constructor is to set these instance variables. So that's where I was trying to put these things. If I want to be more specific, I can use a special keyword called this to access those. In fact, I'm a big fan of using this, even when it's not strictly necessary for me to do so. You'll find that I'll include it just to be explicit about the fact that, yes, I am accessing an instance variable here. It just helps me visualize that even more clearly. The text turns blue as well. That's another good visual clue that Eclipse gives you. But seeing that keyword this out in front is another good visual clue that we're referring to an instance variable here, not this parameter. And so now this constructor has the ability to create rectangles of all different varying lengths and widths because I can call this constructor. And in fact, let me go ahead and do that. I'm going to create another file. I'll call it tester. I'm just going to do some testing over here. And I want to try this out. I want to use the constructor to create, we would call this an instance of the rectangle class. So the class itself is just a template. It's just a blueprint, right? Notice I don't mention any exact values here anymore. There's no constants. This is just a template. This just shows me how to make various kinds of rectangles with various types of lengths and widths. If I actually want to do stuff with a rectangle, I need to create one. I need to actually make a concrete rectangle. And I can do that by creating an instance, by calling the constructor. So let me put a main method in here. And I will create an instance of the rectangle class, just like we would create any other variable. The first thing that comes is the type. The type now, though, isn't going to be int or double or even string, but the type of the thing that we wish to create is going to be rectangle. I wish to create a rectangle, right? I wish to create a rectangle. Anything that I put into a class, I can now use this as a type. So I wish to create a variable with the type of rectangle. R equals, and now in order to call the constructor, there's a special word that you see. You've already seen this word, new. Anytime you see that word new, that means we're creating a new instance of something. That means I'm about to call a constructor. I'm about to create a new instance of an object. In this case, the instance of an object, it's going to be a rectangle object. And now I have to provide some actual values here. These could be in variables if I have them, but I don't, so I'll just go ahead and plug in 9 and 3. Right? That'll create one instance of a rectangle with a length of 9 and a width of 3. If I want to, I could make another rectangle here with a length of 9.5 and a width of 10. Okay. And so now what I have are two distinct rectangles, right? Each one calling the constructor and then storing these values in the instance variables. I haven't actually defined any methods yet, so we're not actually really doing any work. But let's try some things here. Let's go ahead and come back to our tester and print. I'm just going to print out this rectangle. And actually, let's just print them both out and see what happens. I want to show you that, yes, I do in fact have two distinct rectangles. So I go ahead and run this code, printing out rectangle R and R2, and you see down here at the bottom, I get some stuff that is not particularly helpful. It says, well, there's rectangle at, and then I see some gibberish here. These are addresses. These are memory addresses. This is quite literally where on the computer these rectangles live as a number, which is kind of interesting, I guess, but not particularly useful. I was hoping to see the length and the width. But the reason why it didn't show me that is because, you know, I haven't told it how I wish for this rectangle to be displayed to me when I print it out. The way that we tell the computer that is by using the tostring method. So I'm going to come back in here and I'm going to add in our first method. The tostring method takes our object and converts it into a string. It's used often for debugging purposes. Typically what we want to do is allow it to decide which of our instance variables are critical enough to be shown, right? And then just concatenate them together in a string, hopefully, usually with some labels. If your object is simple enough, you can do this in one line. So I might do something like length plus this dot length plus comma width plus this dot width. If you have a lot of instance variables, you could see that this line of code would get pretty long. Actually, there's another trick that I might show you a little bit later involving tostring. But notice that once I include this tostring here, Java, this is a special method that Java knows about and will go looking for whenever I try to print out an object. It'll try to look for this tostring method and use that representation. So now when I run this code, you can see that instead of seeing what it had before, I've now actually given it instructions on how to display these, and I can see that here's the objects, right? Here they are. And so what might be interesting too is if I come down here and I try to change one of these objects. So let's say I want to change the length of this to be something else. I don't like the one that I create. I want to change it. So I might try something like this. I might say r.length. R is the rectangle that I wish to change the length of, dot, and then the name of the instance variable. And here you can see that because this is, it says it's not visible, it's marked as private, right? It's marked as private. Okay. So I can't actually see this. In fact, even if I just tried to print this out, I believe that it would get unhappy. So I can't even just print this instance variable out. So I can't change it and I can't print it. I can't access it at all. And the reason for that is because it is marked as private, right? If I come up here and I switch this to public, Eclipse will stop complaining. And so you might be saying to yourself or thinking right about now, okay, well, why are you telling us to mark everything as private? It seems like that is just making things harder for us. The answer is that we don't necessarily want people to be going in and messing with our instance variables. That defines our objects in a very particular way. Or maybe, we do want them to be able to manipulate our instance variables, but there's a certain way it needs to happen, right? There's a particular way that they need to be updated. They can't just be any values, right? Consider if I try to say something like this, right? Try to set length to be a negative value. Now we're getting into, sort of imaginary numbers land, which is a direction that we maybe didn't want to go into. Maybe I didn't want to allow stuff like this, right? If it's marked as public, there's nothing I can do to stop it. If it's marked as private, right? It gives us more control over how our instance variables are accessed. So instead of accessing them directly like this, what we should be encouraging people to do, and doing ourselves actually, is marking our instance variables as private and then providing special methods called accessors, getters and setters. So public double get length. Return this dot length, right? Public double get width. Return this dot width. These are examples of accessor methods, or you might also hear them referred to as getter methods. Very, very common to include them as a way to allow people to view these values. Notice that we still cannot necessarily change these values, but that's kind of the whole point, right? If I mark these as private, I can now provide a getter to allow people to access those values if I want to, right? I can now call this method, which will give me that value. It'll let me read that value, but I still cannot do stuff like this, right? I still can't modify it. So it's secure. It's very secure. If I want to allow them to modify it as well, I can still do that. So I can actually still provide that as an option by providing what's called a setter. They all follow a pretty similar format. This time I have a parameter coming in. And typically I would just do something like this. Now at this point, right? At this point, the way I've coded it up, the length instance variable is, for all intents and purposes, public, because there's both a getter and a setter with direct access. So if you do that, it's functionally equivalent to just marking it as public, right? I'm still a big proponent as marking things as private though, and only exposing them as necessary. That's sort of the idea. Furthermore, we talked earlier about how we might want to restrict values. So perhaps I only wish to set this if length is greater than 0, right? Otherwise, I'm just going to ignore that value. Now I've provided some protection, right? If it's marked as public, they can set this to be any value, any acceptable double, negative, positive, whatever. If I mark it as private, I can provide a getter and a setter, and I can provide specific ways to modify things or access things if necessary. So that's why you'll always see instance variables marked as private at the top of classes in Java. Okay. Back to the task at hand, we've actually already created a few methods for this object. Accessor methods, so getters and setters, a tostring method, and I've actually already showed you how to call those methods as well. If I wish to call a method within a class, I first create an instance of that using the constructor. That instance is now in this variable, and then I call the method on that instance, right? Note that once I put that getLength method in, I can call getLength on both of these, and what you'll see is that I get two different answers back, which makes sense, right? They have two different lengths. These are two different instances of the rectangle object. In fact, we can even see that through the debugger, right? If I set a breakpoint here on line 10 and then start the debugger, over in the variables window, we can see our two objects. We can see our two object instances here. You can see that R has a length of 9 and a width of 3. R2 has a length of 9.5 and a width of 10. But I actually want to show you something else real quick while I'm here inside the debugger. I'm going to click Step Into, which is going to take me into the rectangle class. And note now, right? I called this on R. I called this on R. R.getLength. I'm now within the rectangle class, and it says return this dot length. And over here on the right, it now says this, where this has a length of 9 and width has a value of 3. So I can see clearly that this is referring to the same rectangle that R is, right? So this line of code, the line of code that's highlighted, the word this is referring to R. But if I keep moving, so let's keep stepping, that line is finished. There it printed out the value. I'm now going to call getLength on R2. Let's step inside that. I now see, here we are on the same line of code. If I look at the debugger over here, I now see this refers to length 9.5, width of 10. That's R2. That's R2. So when using this in our code, think more generally, right? You have to think in abstract terms. What is this? This is the instance of the object that the method is being called on. That is the most succinct way that I can think to define it. The word this refers to the instance of the object that this method is being called on. When I called r.getLength, this refers to r. We saw the values. When I call r2.getLength, this refers to r2. We can see the values here referring to r2. So that's what the this keyword refers to. Okay? Cool. All right, we've covered constructors, accessors, getters and setters, tostring. Let's move on to actually creating some methods, some behaviors. So some other parts of the instructions here, we can see a rectangle should be able to. So that's the other kind of phrase that you should be looking out for. Anything that you see verb, that it is verb-like, should be able to, can do. A rectangle can indicate something. A rectangle can indicate. So you see that, right? You see that, excuse me. They're referring to verbs, behaviors, things that a rectangle can do. Those are going to become methods. So a rectangle should be able to provide its area and perimeter. That's referring to some methods that we're expected to write. And I would even try to make the names of those methods as verbs. Anytime I'm creating a method, we have to think about the return type. So the perimeter and the area are probably going to be doubles, as well as our length and width. And I would probably say compute area, right? That's a good verb. The parameters, it doesn't actually need any, right? I'm computing the area of this rectangle, whatever rectangle this method is being called upon. So the area is just the length times the width. This is pretty simple. Okay. For the perimeter, it's a similar idea. It's going to be 2 times this dot length plus 2 times this dot width. Oh, whoops, sorry. I was still in the debugger. I forgot to switch back over to Java mode. That's what that message is trying to tell us in a very long-winded sort of way. So here I've created a couple of behaviors, a couple of methods that we can use on our rectangle. So here, instead of saying, r2.getLength, I could say r.compute_perimeter. And same for r2. And let's see what these values are now. 24 and 39, right? That's math appears to be correct. 18 plus 6, yeah, appears to be good. Okay. Those two are pretty simple, straightforward methods. Let's take a look at some of the other ones. Here we go. A rectangle can indicate whether it is smaller than another rectangle in terms of area. This one is a little bit complicated, and this is one that throws a lot of people, that kind of stumps a lot of people. How do we do this? How do I check a rectangle against another rectangle? I see people create methods that look maybe something like this. Public, Boolean is smaller rectangle. So first is the idea that we can use rectangle here as a type, right? The parameters have types. I already explained earlier in the studio that our class is being used as a type now, and so I can use rectangle here as a type. But then it's common to see something like this, rectangle R2, have 2 rectangles coming in here. That's actually too many, right? Remember that we have this rectangle as well. So in order for this method to get called, I have to have an instance of the rectangle class, right? I have to have an instance of the rectangle class. So this rectangle is one rectangle, which means that I don't need two rectangles coming in as parameters. I really just need, I just need one other rectangle coming in as a parameter. I really just need one. And there's a few different ways that you could, conceive of whether rectangles are bigger or smaller than the other. Does it say actually how to compute that in terms of area? Perfect. Okay. So this could actually be a one-liner. Return. Remember, this is one rectangle that we have. Dot compute area is less than other dot compute area. Compute my area and see if it's less than the other rectangle's area that it computes. Remember that whatever this refers to depends on when this method is called, depends on when this method is used. So if I go back to my tester here and I want to say, all right, I'll say system.out.print r.is smaller r2, and then we'll also do the reverse. R2 is smaller r. I'm going to run this through the debugger again, just to re-illustrate this point, because I believe it's that important. It's a pretty critical point, right? Okay, here we go. So here I'm taking a look at the first call, r.isSmaller. R is the instance upon which the isSmaller method is being called. So R is going to be this when I run through the method. Right? If I step into the code here, you can see that this refers to R. Other is coming in as the parameter, so here's R2. I believe this rectangle should in fact be bigger, so isSmaller should be true here, I believe. And we see that true in fact gets printed out. But then when I reverse them, I would expect to see the reverse here. So because R2 is associated with the method call, R2 dot is smaller, it now becomes this. And I can see this dot compute area less than other dot compute area would have the opposite effect now. It's going to be false. Okay? There it is. Terminate. All right. Let's take a look at what else there was for this one. A rectangle can indicate whether it is in fact a square. Okay, so a square would be if the length and the width are the same. We can implement this one last method here. Oh, not double. Why did I do double? There we go. I think that'll do it for our rectangle class. There's certainly more that you could do here. We included standard draw. I think the idea of creating a draw method is actually really cool and something that may come in handy later on. Hint, hint, wink, wink. But having a public void draw method that then has calls to standard draw in here, I think is actually a really, really cool idea. Something that I would encourage you to experiment with, play around with if you have some extra time. You want to keep working on these objects a little bit more. Base this on the length and the width, for example. But what I would like to do is go through one more example of an object with you. I'm going to go through this one a little bit more quickly, right? Because I've already touched upon a lot of these concepts, and I also kind of want to show you a couple of little shortcuts, a couple of little things that you can use that I would encourage you to use as well. So let's talk about fraction. I may not get through the entire fraction class, but I'll do as much of it as I have time for. I've got another good 15-20 minutes left that I can spend on this. So if we take a look at the description here, excuse me, a fraction has a numerator and denominator. Boom, there's our instance variables, right? Oops, made a mistake already. Private double numerator. Actually, do I want it to be a double? Probably just want it to be an int, right? Okay. There's our instance variables. Now, I was talking before about how you can include accessors, getters, and setters. In fact, this is a pretty common process to do. So one thing that I wanted to show you is that you can actually have Eclipse do this for you. It's a pretty common thing to have an IDE do this for you. If you come down to, let's see, I'm looking for the source menu. You can see there's a method here for generate getters and setters. So I can select getters and setters to create. Which ones do I wish to create here? Do I want to create getters and setters for both, or just, just getters? I think I might do just getters in this case and not setters. You can see there's buttons over here for getters and setters. I can switch some, options down here if I want to, but I'll just go ahead and do that. And boom, there's my getters and setters generated for me automatically. It's a pretty common thing to do, so we made a way to make it simple. Same thing for tostring. So if I want to, I can right-click and go to the code menu, or the source menu rather, and there's an option here for generate tostring. So let's do that. I need to select which fields I wish to see. So if you have a lot of instance variables, you may not want to include all of them. So think about which ones you wish to include. In this case, I only have 2, so I'll include all of them. And I'll hit generate, and you can see that it just has this auto-generated string that it creates for us down here. And this can help us get up and running pretty quickly, right? The other thing that I really need to get up and running is a constructor, which I'll go ahead and create. And I'll take in both the numerator and the denominator as parameters and set them. So this is, this is our fraction class. You can see how quickly I was able to get that up and running with the help of Eclipse. And with the, the basic knowledge that instance variables are going to be private, and, I can decide what getters and setters to include, and the general idea behind tostring allows us to very, very quickly get a class up and running. I mean, I can come back over here already and, make a new fraction. 2/3, right? And then print it out. There we go. Numerator's 2, denominator's 3. Now, if you don't like the formatting here, you want it formatted a little bit more fraction-like, you can always go back in and, change the way that looks. But this is certainly fine. Okay, let's take a look at some of the behaviors, see how far we can get. A fraction should be able to add itself to another fraction, returning a new fraction that represents the sum. All right, let's think about this one for a second. We've already seen this idea of, if I have to combine 2 things together, don't forget about this, right? So that same concept is going to apply here. If I wish to create an add method, I think it's cool. A cool idea to, add in a fraction, right? Also note the return type here is going to be a fraction as well. If I add 2 fractions together, what do I expect to get back? But yet another fraction. I think it's also important to, well, I'll hold that thought for just a second. We'll come back to what I was thinking about in just a moment. So I have 2 fractions. I have this fraction, and I have the other fraction. And in order to add 2 fractions, oh my gosh, you're going to make me think about fraction arithmetic? I haven't had lunch yet. In order to add 2 fractions together, we need to, the denominator needs to be the same, and then we just add the numerators together, right? I'm going to cheat a little bit. We know we can make the denominators the same by multiplying them together, right? Or maybe I should have started with multiplication, since that's not as tricky as, is that on here as well? Yeah, multiply itself. Maybe I should have started with multiplication, since that's actually a little bit less tricky than division. since multiplication of fractions is just pretty straightforward. Yeah. I'm going to start with multiply. More because I just don't want to think about the math and I'm focused on the code. So let's first compute our new numerator and our new denominator. To multiply two fractions together, we just multiply the numerators and the denominators. So the new numerator, which, say that 10 times fast, is equal to this dot numerator times other dot numerator. We can say other dot numerator here because we are within the fraction class, so the private does not apply since we are within the same class. However, it should be noted that get numerator also does the job just fine. Nothing wrong with that. And so we'll make our new denominator in a similar fashion. Now, it's important to note that the instructions clearly say that we should return a new fraction that represents the product and the sum. And I think that's important. The idea that we're really trying to get you to is that you can and should create a new fraction here, right? With the new numerator and the new denominator. And do it that way. Why are you upset with me right now? Oh, because I used doubles here instead of ints. My fault. Overcomplicated it. Okay, cool. And so there's actually three fractions at play, right? There's the two fractions that are being multiplied together, and then the third fraction, the product that is coming back out. You might say to yourself, well, is it really necessary to, create this fraction and bring another fraction into existence? First, I want to show you that, it works and that it's clearly not wrong. And then I want to argue why it's actually necessary to do it this way, or better to do it this way as opposed to some alternatives that you may have tried. So let me create another fraction that we can use to perform some multiplication very briefly. I'll create 1/2 as a fraction. So that's pretty simple multiplication, right? Should get 2/6 back out, which is 1/3 if we want to reduce, but it didn't ask us to reduce, so I'm not gonna, right? So I actually want a system.out.println f.multiply f2. There we go. Let's do that. All right, here we go. I get 2/6, which is the answer that I expect. So this is clearly not wrong. This is clearly not wrong, right? But let me show you another another common approach that I see people try to take here, which is that instead of doing this, we might, just instead of creating new variables, maybe we'll just say something like this. This dot numerator is equal to this dot numerator other dot, and then we'll just modify this, right? Or I could modify other as well if I want to. So now I don't need to make a new fraction. I can actually just return this if I wanted to. Or, other. These are fairly equivalent, actually, in my mind anyway. A little easier, I think, to see what I'm trying to do here if I use other, right? So now there's only two fractions. There's only two fractions involved. Right? The two that I'm multiplying together, and then the result is going back into other. But I want to show you why this is a problem. If I come back here and I run the code and I want to see the result, right? I can see that I get the same answer back out. So, okay, it worked. What's the problem? Well, let me add one more line here. I want to print out f2. Okay, f2 is now also 2/6. Well, how did that happen? I thought f2 was 1/2. If I look at this code and I print out f2 and it tells me it's 2/6, I'm a little bit confused because to me it looks like it should be 1/2. How did that happen? Remember, inside of our code here, I didn't create a new fraction. I said other.numerator, other.denominator. If I'd said this, it would have been the same problem, but I just would have been changing f instead of f2, right? It would have been the same problem. By creating that third one, so let me hit undo. It'll let me go back far enough. There we go. By creating this third fraction and returning that as our result, it allows us to leave the others untouched. So if I run this code now with my updated result, you can see that the original fraction, f2, remains untouched. Okay? It's an important concept. Typically a bad idea to mess with those parameters that are coming in or this, unless you have a very good reason to do so. Okay, I am almost out of time for this studio review, so I wanted to take the last few moments that I had. I know I didn't get very deep into fraction, but I spent about as much time on it as I was hoping to. The rest is honestly probably more a review of fraction arithmetic than anything, which I know is everybody's favorite. But I wanted to take a moment to just sort of talk to you about assignment 7 to wrap up this studio review. We've given you a whole bunch of tests. We're using what's called test-driven development here, which is the idea that we write tests first, and then our goal is to get our code to pass the tests. So we're going to write a little bit of code to hopefully pass 1 or 2 tests, and we're just going to focus in on getting those tests to pass before we move on to the next one. So there's 2 classes we wish for you to create, a student class and a course class. I think most people, have a pretty good time with the student class until they get to GPA, perhaps, is a problem. Bare bucks is another one that can be kind of a tricky issue to deal with. Consider for grade point average that you're going to have to, remember values over the life of the object. And so anytime a grade gets submitted, you have to make sure that those values get updated properly. Is the biggest advice that I can give to you. And use the debugger. Use the debugger in much the same way that I showed you to create examples, submit courses, and step your way through the code to see what instance variables are getting updated and how to make sure that you're doing this properly. For the course class, so a lot of people think, all right, this is going to be easier now that I've gotten one out of the way, but the tricky part here is this roster of students. So I don't want a roster of student names. I want a roster of students. That's the first thing that I see that people misinterpret here. If you have just strings representing the students in your course, you're going to have a problem because later on I'm going to ask you to calculate the GPA of the students in this course. And if all you have are strings, you're not going to be able to do that, right? You're not going to be able to tell me what that GPA is. So it's not strings that I'm looking for, but students, student objects. And then the other idea is that there's going to be more than one student here, right? There's going to be more than one student in this course, presumably. There's going to be many students. We've talked about containers that we can use to hold many things, but it feels a little bit weird to think about how I might have an array of students, for example. Actually, though, that's exactly what you need here, is an array of students. This instance variable, I feel comfortable, giving you the big fat hint, telling you that this should be an array of students. There are other ways to do this, right? If you've been programming for longer, you might think of more solutions than an array of students, and that's fine too. But for what we know up until this point in the course, I would expect you to use an array of student objects here. Think about what that means. In the constructor, right? Remember that the constructor's purpose in life is to make sure that every instance variable is set to a value. If the instance variable is an array of students, I need to initialize that array. I need to tell the computer how big that array is. That needs to happen in the constructor. So think about that. Think about how you would do that. That's a big, big, big hint, a big problem that students often run into with this particular assignment. Okay, I think that's going to do it for me. I think that's going to do it for this studio review. If you have any questions, as always, please come on into my office hours. I'd love to talk to you. I'm seeing more people come into office hours lately, which is great. Please keep it coming. I love talking to people about this stuff. I've heard that, it could be helpful to come in and even just have 15 minutes to talk to me about a concept. Hopefully, if it helps you out. We got a big exam coming next week. I'd be happy to talk to you about anything related to the exam as well. Just let me know what I can do. But I hope you all have a great weekend, and I will see you in class next week.